One case of extreme tastes are those for goods that we can't tell the difference between, like Coke and Pepsi in graph 5.1. Another extreme will be the case where two goods are so intricately linked in the minds of consumers that they can only be consumed together, and the consumer cannot imagine consuming more of one without also consuming more of the other. In one of the end of chapter exercises, we give the example of right and left shoes. Most consumers always want to consume those together and derive no additional happiness from getting only additional right shoes or only additional left shoes. Here we're going to use instead the case of my wife's tastes for iced tea and sugar. For my wife, glasses of iced tea and packs of sugar are like right and left shoes. Together, one pack of sugar and one glass of iced tea form a perfect beverage. More sugar, and she doesn't get any additional enjoyment because she won't use it. More iced tea, no additional enjoyment because she won't drink it. They have to be in a ratio of 1 to 1 because of her peculiar obsessive compulsiveness. Thus, one glass of iced tea and one pack of sugar give us one beverage for my wife. If she starts out with one glass of iced tea and one pack of sugar, and we give her a second pack of sugar, she gets no happier. Thus, the second bundle we've drawn must lie on the same indifference curve as the original bundle. And the same is true for any number of packs of sugar we give her beyond the first, as long as we keep her iced tea glasses at exactly 1. Thus, part of her indifference curve is a straight vertical line that extends from the original bundle 1, 1, which represents one perfect beverage for her. Similarly, if she again starts with a perfect beverage of one pack of sugar and one glass of iced tea, and we give her a second glass of iced tea without any additional sugar, she doesn't become any happier. Thus the bundle that contains one pack of sugar and 2 glasses of iced tea must lie on the same indifference curve as the one that contains one pack of sugar and one glass of iced tea. The same is true for any number of iced teas above 1, as long as we don't give her any additional sugar. We therefore have the second part of the indifference curve as a horizontal line that extends from the initial bundle 1, 1. But if we start at the initial perfect beverage with one pack of sugar and one iced tea, and we give her one additional pack of sugar and one additional glass of iced tea, we now have 2 perfect beverages, and that must lie on a higher indifference curve. The shape of that higher indifference curve must then have the same shape as the lower indifference curve for exactly the same reasons as before. And we can keep going the same way. If we start with 2 perfect beverages and we give her one additional pack of sugar and one additional glass of iced tea, she now has 3 perfect beverages. That again lies on a higher indifference curve, but that indifference curve again has the same L shape. Giving her any additional packs of sugar without additional iced tea, or any additional iced tea without additional packs of sugar, will not make her any better off. Whenever we have perfect complements that must be consumed together as pairs, we can set the units just right so that all the corner points of the L-shaped indifference curves will lie on the 45-degree line. However, we could also measure the units differently, and the corners would then lie somewhere else on a ray from the origin. What's important is not where the corners lie, but the shape of the indifference curves as L-shapes that indicate that the 2 goods must be consumed together in some ratio. We therefore now have 2 extreme cases, the case of perfect substitutes, which gives straight line indifference curves, and the case of perfect complements that gives L-shaped indifference curves. In the next graph, we'll see that there are many in-between cases, and we can tell whether they are more substitutable or more complementary by checking them against the extremes.